let's discuss about transpose of a matrix. Now, transposing a matrix is a very simple operation. Here we convert row to column and column to row. Okay, so this is what we mean by transpose of a matrix. Okay, so what do we do here? We convert row to column and column to row. Okay, so this is basically what we mean by transpose. Let's take a simple example. Now, I'm not going to take a square matrix in the beginning. Let's start with a very simple one, a rectangular matrix. Okay, so in a rectangular matrix, let's say I'm going to take, this is 1, 2, 5, minus 1, minus 7 and say 3. Now, the order of this matrix is 2 cross 3. Now, when we transpose, so what we write is we write it as A transpose, A superscript T, or you can also say A dash. This is also transpose. So, this becomes, see here, 2 cross 3, row becomes column, column becomes row, correct? So, the order of this matrix will become 3 cross 2. In the sense, so I'm going to have a matrix with 3 cross 2 as the order. 3 rows, 2 column. Now what's going to happen? See here, this is the first row, correct? Row becomes the column. So 1, 2, 5. This is the first one. Next, the second row, this is the second row. That becomes the second column, which is minus 1, minus 7. This is 3. So, this is basically a transpose. Okay. Now, a transpose of a matrix. Now, if you take a square matrix. Okay. Now, let's take a square matrix and let's look at the example. The matrix what we have, say you have matrix B is equal to, I'll take a 3 cross 3 matrix, which is the most commonly used matrix. Say 5, 2, 1, 7, 0, 8, minus 2, 3, 11. Say this is matrix B. Now when you do B transpose, again, so 3 cross 3, when you transpose, it's going to be 3 cross 3 itself. So what we can conclude from this is, if you have a square matrix, then the transpose of a square matrix is also a square matrix. That means when you are taking some matrix of the order m cross m, then even the transpose will also have the same order m cross m. Okay. Now coming to this example, so here you have 5, 2, 1. 5, 2, 1 is the first row, correct? This is the first row. That becomes the first column. That means this becomes 5, 2, 1. Next, this is the second row. This becomes the second column. So this becomes 7, 0, 8. Then the third one. So third one is this. So minus 2, 3, 11. So now what you are seeing, this is basically the transpose of matrix B. Alright. Now there are certain properties of transpose of a matrix. What you guys have to know. Okay. Not many are there. Maybe around 2 are there. That's all. Fine. Now the first very important. So I can say that this is a property. Okay. So properties of transpose of a matrix. So in this, see the first property is that suppose if you have A plus or minus B whole transpose. Whole transpose. So this becomes A transpose plus or minus B transpose. The transpose becomes individually you can do the transpose. Alright. The second property what you have is, suppose if you have A transpose and for that we do transpose again, then you are going to get A back. Isn't it quite obvious that you do a transpose of a transpose? You are going to get the matrix again. Okay, then the third property. Now, third property is quite important because you will have certain proving problems based on this property. The property is, suppose if you have A into B whole transpose, this becomes B transpose into A transpose. Okay, so of all the three, I would say this is very important. Okay, so this property is quite important. Fair enough? Now that you have understood what is transpose of a matrix, now there are two types of matrices which are very special. I mean, they have a special meaning to that particular matrix. Okay, now in the next video, you will understand what are those matrices and properties of those two matrices.